Let's talk about function notation. So once we've determined that either a graph or specifically a formula is a function, so only one output per input, we can change from using two different letters, and our default, of course, is input x's, output y's. We can change it, or we kind of drop the output letter and we replace it with f of x. So we have, usually the letter f is the first one we use, but this can be any letter. So here we have f of x with those parentheses, and then we have our formula. So it's sort of exactly the same thing, but it allows us to refer to y values in a more direct way. So you can see all the examples we're about to do. So we could also do this as g of x equals 2x minus 3, sometimes h of x, whatever. They all just mean whatever you're plugging in, you do 2 times that number minus 3. One important thing to try to get your brain used to at the beginning is these parentheses, because up until function notation, parentheses have always just meant multiplication, right? So we're like distributing things in or multiplying numbers together. When this outside here is a letter like this, it's not multiplication, even though the notation is exactly the same. So we would not say this f times x, this is always f of x. Okay, so let's try this first example here. F with the 0 in parentheses here, I would say this out loud, f of 0. And what it wants you to do is compute the output or the y value that goes with x equals 0. So once the number is in that spot, they're telling you that's the x value. So we're going to go to this formula and say, okay, if the x is 0, that tells me 2 times 0 minus 3. So that would be 0 minus 3 is negative 3. So f of 0 equals negative 3. That tells me like when x is 0, y is negative 3, or you could say it as 0, negative 3, the xy point is on the graph. Let's try it again with negative 2. So we have f of negative 2. That means negative 2 is going to get plugged in for the x value up here. 2 times negative 2 minus 3. That's negative 4 minus 3 is negative 7. And again, that would mean that negative 2 comma negative 7 is an xy point that's on the graph if we were going to try to start graphing this. All right, we'll do one more with a number, and then you can see we're going to get weirder and weirder at the end here. Oh no, I drew on it. Okay. All right, so f of 5, we'll do 2 times 5 minus 3. 10 minus 3 is positive 7. Okay, so we'll try to ignore my little zigzag here. F of p. Why would you want to do this? We don't really have a reason yet, aside from it's part of the problem. My point with these last three, though, is just that like you can use function notation to plug anything into anything, and it still kind of works the same way, even though it's a little bit less intuitive to our brains than these first few examples. So this f of x notation, this just means f of whatever is 2 times whatever minus 3. So if you're plugging in p, you can just do 2p minus 3. If, for example, you're doing x plus h, f of anything is 2 times that minus 3. So I'm going to put an x plus h here in parentheses to show that all of it is multiplying times that 2. So I don't need to simplify it here, but if I did want to simplify, I might distribute the 2 into these parentheses, so it's 2x plus 2h. Finally, we have x squared, just another thing that's kind of awkward on the brain to plug in. Again, f of anything is 2 times that minus 3. So we'll say 2 times x squared minus 3. Because this doesn't have a plus or minus sign like in it, it's only one term, so I don't have to put the set of parentheses here. They can be there or not, and it's correct both ways. Okay, so let's see similar examples, but with a more complicated function. So here we have a quadratic function. So here we'll use f of x as x squared plus 2x plus 1. And what makes this more annoying, I guess, or more work, is that it has 2 different x's in the formula. So the change is just whenever you're plugging something in, it goes into both of these spots. So if I want to write this in like the parentheses notation, it's whatever squared plus 2 times the same thing plus 1. All right, so if I do f of 0, I'll put a 0 in these spots. That 0 plus 0 plus 1 is 1. Okay, if I do -1, I want to be careful, especially with that square. -1 squared plus 2 times -1 plus 1. -1 squared is -1 times -1, so that's +1. 2 times -1 is -2. And here I have 1 minus 2 is -1. Plus 1 is 0. Okay, now let's plug in some weirder stuff. So f of p, it's going to be just the exact same formula you see here, but with the x's swapped out for p's. So I have p squared plus 2p plus 1. Why not? All right, now f of x plus h. This is something that once we start talking about derivatives later on in the semester, this is going to be something that we need to compute a lot as part of a bigger formula. That's why we're practicing with it now, because it can be really tough on the brain to kind of execute this step. So because of the x in here, I'm going to look to this version of the formula instead, the one that doesn't really have an input variable, just an input spot. So whatever I'm plugging in goes here and here in parentheses. So I'll have x plus h squared in parentheses plus 2 times x plus h plus 1. And again, for the sake of this problem, we don't need to expand this. But if we did, in the course of something else, we would have to FOIL this out, x plus h times itself, distribute the 2 into these parentheses and so on. All right, one more, f of x squared. Again, I'm going to use this to help me out so I don't get distracted by the other x's. I'll put x squared here and here. And we have x squared squared plus 2x squared plus 1. All right, this one I actually am going to take a step to simplify, just to be clear. So when we have x squared in these parentheses, it's getting squared again. So it's x squared times another x squared. We're actually multiplying these exponents together. So this is x to the 4th plus 2x squared plus 1.